Every second, organizations generate massive torrents of raw data. Left unmanaged, these data streams are chaotic, overwhelming, and impossible to leverage for actual decisions. To bring order to this environment, database professionals use SQL Server Management Studio, or SSMS. It is the industry standard interface built to organize, query, and secure these complex information systems. In the next 6 minutes, we are going to build a functional data environment from scratch. We will connect to a server, construct a database, run a verification query, and secure the whole thing with a system backup. Before we begin, you need the software installed on your machine. You also must have your specific server name and your login credentials ready. Mastering this initial sequence ensures your connection is stable and your configuration is valid before you begin importing or managing live records. Step 1 is breaching the blank interface. When you first open SSMS, you need to bring up the Connect Object Explorer dialog box to gain entry to your environment. This is exactly where most initial setups fail. You must ensure your server name is typed perfectly and your authentication type strictly matches the credentials you were issued. Once you hit Connect, look to the left side of your screen. If the Object Explorer populates with a hierarchical list of folders, you have successfully verified your connection. Now we need a place to put our data. Navigate to the Databases folder in that list, right-click it, and select New Database. The system will prompt you for a name. Use clear, descriptive naming conventions here. A title like Sales Data 2024 prevents massive administrative confusion down the line compared to a generic label. By saving this, you've created a secure, isolated container. This specific database will now protect all the structural operations we execute next. Right now, that container is completely empty. To actually hold targeted sets of information, we have to build the internal architecture by creating tables. A table requires strict rules. We define specific column names and then assign rigid data types to each one. This ensures incoming data matches our format. Once set, save the configuration with a definitive name, like Customer Records, locking that architecture into place. At this point, many users hit a common interface glitch. You look back at the Object Explorer, and your new table is completely missing from the list. Your work isn't gone. The user interface simply hasn't caught up. To fix this immediately, right-click the Tables folder and hit Refresh to force the system to display your current architecture. These column definitions act as a primary filter, blocking invalid data types from entering this specific table during future operations. With the architecture built, we have to verify it works. Click New Query at the top of your screen to open the SQL Query Editor. As you start typing your code, you'll see a feature called IntelliSense kick in. It predicts and auto-completes your table and column names, speeding up your workflow and catching spelling errors before they happen. Before executing anything, check the Database Selection drop-down menu. If it says Master, change it to your newly created database. Running test scripts against the system's master database is a critical operational error. Type out a standard select statement targeting your new table and hit the Execute button. Look at the results window at the bottom. Even though we haven't added any actual records yet, you should see your defined column headers populate cleanly across the grid. Seeing those columns load successfully provides your proof. Your database architecture is structurally sound and fully prepared for live data ingestion. Now that we have a verified working asset, the final step is locking it down to protect against data loss or file corruption. Go back to the Object Explorer. Right-click your specific database, navigate to Tasks, and select Backup. For this initial safeguard, you can leave all the default parameters exactly as they are and execute the command. Wait for the progress bar to finish. You are looking for a definitive visual confirmation pop-up stating the backup completed successfully. With your baseline protected, you can start looking at advanced administrative features. The next logical step is setting up role-based access control in the Security tab, ensuring unauthorized users are restricted. In just a few minutes, you've completed a full setup cycle. You connected to a secure server, structured a robust data container, verified its integrity with a query, and established a restorable backup. With these 4 steps complete, you have a functional, protected environment ready for more complex SQL development and administration.